In this video, we are going to talk about Hinge theorem and indirect proof. Hinge theorem is a theorem that talks about inequalities between two triangles. So notice in this Hinge theorem, and again, if you need to pause the video to write things down, please do so. It says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. So notice that I have to have this angle in between these two congruent sides, okay? So 88 is a lot bigger than 35. Therefore, WX is going to be bigger than, so we'll put 4 tick marks on that one. It's going to be bigger than ST. I'll only put 3 on that one. Okay, so that's what the Hinge theorem says. And then we have the converse of that Hinge theorem. So if I know that two sides of one triangle are congruent to two sides of another, and I know that the third side of the first is longer than the third side of the second, then the included angle of the first, the one across from the longer side, this angle is going to be larger than the angle across from the smaller side. So angle C is greater than angle F. Okay, so that's Hinge theorem and the converse of the Hinge theorem. You need to know those in case we use those inside a proof. Okay, so how does the measure of ACB compared to ACD? Okay, so notice that we have BC and CD are congruent, and then we have AC is reflexive for both of them, so that's congruent in there. So we have to be talking about the angle in between those two. So I'm comparing ACB, this one, to this one. So I'm not really marking them congruent, I'm just marking them so we know which angles we're doing. So then I look across from those angles to see if the sides are bigger. So 16 is larger than 15, so that means this angle up here is larger than the angle below. So angle ABC, the measure of angle ACB, is going to be bigger than the measure of angle ACD. So now let's look at the exterior angle inequalities. Okay, this is actually in our book, and it says if the measure of an exterior angle of a triangle is greater, if you remember we talked about exterior angles, we're talking about this one here, is greater than the measure of either of the two non-adjacent interior angles. So they're talking about angle A or angle B. So angle 1 always has to be greater. And if you think about it, doesn't that make sense? Because didn't we say the measure of angle 1 is equal to the measure of angle A plus the measure of angle B? Okay, so the measure of angle 1 has to be bigger than either one individually. Okay, so we're going to use that relationship to explain how we know that the measure of angle 1, we just talked about that, how the measure of angle 1 is why it's greater than angle A and why the measure of angle 1 is greater than B. Okay, and in this one, pardon me, in 28, so the person here marked these two angles congruent. Well, this angle here is an exterior angle. So it cannot possibly be congruent to angle D. And so we could say by the exterior inequality theorem, angle FEG must be greater than, I'll say the measure of that, must be greater than the measure of angle D. Okay, by the exterior inequality theorem. And then here, this is the definition of inequality. That's what we were just talking about. So if I have this kind of relationship, then I know A has to be greater than B. And also, it has to be greater than C as well. Okay. So if we look at this diagram, we're going to list all the angles whose measures are less than the measure of angle 1. All right, so the measure of angle 1, that's right here. Okay, so that's an exterior angle. I'll also look at this diagram. We have some sides marked congruent. So let me get rid of that arc. This first triangle on the left is an isosceles, so that means angle 2 and angle 7 are congruent. And then the triangle on the right is also isosceles, so angle 6 and angle 5 are congruent by the base angles theorem. So now let's talk about angle 1. Okay, so angle 1 is an exterior angle, and then 7 and 3 are those non-adjacent interior angles. So definitely angle 7 and angle 3 have to be smaller than angle 1. Since 7 is congruent to angle 2, then angle 2 has to also be smaller than angle 1. And then if you think about this as a whole triangle, so look at that whole triangle, then 7 plus 6 and angle 5 are the non-adjacent ones. So definitely angle 5 has to be less than the measure of angle 1. And then since 7 plus 6 has to be less than angle 1, then definitely angle 6 has to be less than angle 1. Okay, so those are the angles that are less than the measure of angle 1. All right, so then now we're going to list all the angles greater than the measure of angle 2. So let me get rid of all my blue stuff. Oh, never mind. I got rid of all of that. That's not what I wanted. Okay, so angle 2, greater than angle 2. So we know that angle 7 is congruent to angle 2. But if we look at maybe some exterior angles, now we just said that angle 2 was smaller than angle 1, so I know angle 1 has to be greater than angle 2. And then angle 4, right here, that is an exterior angle, and 2 is its non-adjacent angle. So angle 4 has to be greater. And then let's see, do we know anything else? We also know that angle 8 is an exterior angle way out here. So exterior angle for this blue triangle, so that means it has to be greater than 2, which is a non-adjacent angle with angle 8. So angle 8 is also greater than angle 2. All right, and then it says which is greater, angle 7 or angle 8, and we have to justify our answer. So, well, we just said angle 8 is greater than angle 2, and since angle 7 is congruent to angle 2, and we know that the measure of angle 8 is greater than the measure of angle 2, then the measure of angle 8 has to be greater than the measure of angle 7, right? We're just doing a little substitution there. So I would actually need, if I was doing a formal proof, I would need to switch my congruence to equals. So speaking of a proof, let's look at a proof. All right, so we have R cubed bisects SRT. So R cubed bisects SRT. That means that angle 5 and angle 3 are congruent to each other. We're trying to prove that the measure of SQR, so angle 1, is greater than the measure of SRQ. SRQ. So that would be angle 5. So another way of saying this is the measure of angle 1 is greater than the measure of angle 5. Okay. So first we write our given. All right, and then, like we said, we're going to use the measure of angle 5 and the measure of angle 3, but those are congruent by what we said, definition of angle bisector. And just like I was saying before, we want to change that to be equals. Okay, so we're changing from congruence to equals, and that's just the definition of congruent angles. That's so we can use substitution. And then we know that the measure of SQR, that's the measure of angle 1, is greater than the measure of TRQ, that's the measure of angle 3. So remember, angle 1 is a exterior angle to angle 3, and 3 is a non-adjacent. Okay, so angle 1, this is like angle 1, is greater than angle 3, if you want to use that. That's our exterior angle inequality theorem. Okay, and then we have the measure of angle 1 is greater than the measure of angle 5. And again, up here is where we said SRQ, that was the measure of angle 5, and then this was 3 TRQ. I know that might be a little confusing with the letters versus the numbers, okay? But all we did was do a little substitution there, like in our explanation on the previous one. Okay, so how is each pair of angle measures related? So if we want to look at ADC, where is ADC? That's this one right here. Versus ADB, that's this one right here. All right, how are those related? Well, we've got two congruent sides, right? So 3 and the 3. And then we have this middle side that they share that's reflexive. All right, so this double arc angle is across from the 5, and this single arc angle is across from 4. So we would say angle ADB is greater than ADC. And what's that theorem called? That's the Hinge theorem. That's the converse of the Hinge theorem. And then if I look at AFB, so let me erase these. AFB is this angle right here, AFB, versus BFD. Okay, so once again, I have two sides marked congruent, and then this one in the middle, they share. So now I'm looking across here and here. So the double arc is across from the 3, and the single arc is across from the 5. So the single arc is actually bigger, AFB. So the measure of angle AFB is greater than the measure of angle BFD. And again, that's by our converse of the Hinge theorem. So indirect proofs. All right, in an indirect proof, we're going to assume what you need to prove is false, and then show that something contradictory happens or something absurd happens. Okay? So basically, assume that the statement that we were trying to prove is false, and then we're going to prove ourselves wrong. Okay, so this is how we recognize when we need to do an indirect proof. It'll generally have the word not, or like a not symbol, or a not equal sign, or something like that. And that's usually a good setup for an indirect proof. Okay, so steps. When writing indirect proofs, our first step is we're going to assume the conclusion is false. And we'll do one in a minute so you can see what these steps look like. Then in step 2, and you'll list these steps out. And then in step 2, we're going to show that our assumption in number 1 leads to a contradiction. So we're going to show our thought process in step 2 of how that leads to something crazy that's false. Either it contradicts the given or any known fact or theorem or postulate. Okay, and then our last step, number 3, is we're going to say, okay, since the assumption that we had was false, then our conclusion must be true. So let's see what that looks like. first, let's just do some practice of how would that assumption look like. That's step one. So we would state the assumption you'd start in these indirect proofs. So if it says, we're trying to prove that AB bisects angle A, then we would say in our step one, we would say, assume AB does not bisect angle A. So you see how we just made it the opposite. Okay, so if in this one, we would say, assume that triangle XTZ is not isosceles. Okay, again, so that first step is just saying the opposite of what we're trying to prove. Okay, and then here we would say, assume that the measure of angle 1 is not, so we could put a slash through there, not smaller than the measure of angle 2. Now be careful here. The opposite of this is not the measure of angle 1 is greater than the measure of angle 2, because that's not the complete opposite. Measure of angle 1 could be equal to the measure of angle 2 and still not be less than that. So just be careful with what your opposites really are. Okay, so let's look at an actual indirect proof. Okay, so it says given M is not parallel to N, and we're trying to prove that angle 3 is not equal to the measure of angle 2. Okay, so this is a great proof for indirect. You see how your proof statement has an inequality, not an inequality, but an equal sign with a slash through it. Okay, so step one, we're going to assume the opposite of our proof. So assume that the measure of angle 3 is equal to the measure of angle 2. So if that is the case, what kinds of angles are angle 3 and angle 2? Yeah, they're alternate interior angles. What do we know about alternate interior angles? If they're congruent. If alternate interior angles are congruent, then these lines have to be parallel, right? That's the alternate interior angle Converse theorem. All right, so if those are parallel, look at what the given says. M is not parallel to N. So we can show then that that's contradicting the given. So that's what step 2 states. It says 2 and 3 are alternate interior angles, and if alternate interior angles are congruent, then lines are parallel. Okay, so if M is parallel to N, this contradicts the given. So you can see how it's just written out. Just our thoughts are written out in words. And then our last step, so we're going to say, therefore, since the assumption, that's from step 1, okay, leads to a contradiction, then the assumption is false, and therefore the measure of angle 3 cannot be equal to the measure of angle 2. Okay, so that's how an indirect proof works. Pretty neat, huh? It's a little more straightforward than the normal direct proofs. All right, so let's try this one. So we've got, let me move this over. All right, we've got the measure of angle 1 is not equal to the measure of angle 2, and we're trying to prove that BD is not an altitude of triangle ABC. Okay, so what do? We say the opposite of the proof. So we're going to assume that BD is an altitude. So if BD is an altitude, then what do we know? Altitudes go from the vertex, and then it is perpendicular to the opposite side. So if that's going to be 90 degrees, then angle 2, that's a linear pair with angle 1, isn't it? So that also has to be a right angle. And then all right angles are supposed to be congruent, so that means the measure of angle 1 equals the measure of angle 2. Oh, there's our contradiction. So we just write that up. So BD is perpendicular to AC, that's by the definition of altitude. And since perpendicular lines form 4 right angles, and angle 1 and angle 2 are right angles, then we know that angle 1 and angle 2 are congruent, since all right angles are congruent. Okay, so then by the definition of congruent angles, the measure of angle 1 equals the measure of angle 2. So you notice how we're switching from congruent to equals, and this contradicts the given. So here's another style of writing that up. All right, so then our last step, you just say, okay, since the assumption leads to a contradiction, our assumption is false, and therefore BD is not an altitude of that triangle. All right, so we will be doing a lot more practice with indirect proofs in class.